So now my question, right? Why does ice float on water, guys? So I want you to guys to actually interact with me using the chat. All right, whatever doubts you have, you can ask in the chat. All right. So go ahead. Waiting for your doubts. Its density is less than water. Okay. What is the speciality of ice that its density is less? Guys, you can use the chat. Elena, molecules and atoms are something which are the particles which are present. So we'll be discussing this more once we start the classes. All right. So when we break down these particles, ultimately what we will get, right? When we break it down, ultimately what we get is atoms or molecules. They are like really, really, really small. Just like when you break down all your body, ultimately each thing is a cell. Similarly, whatever material you take down, for example, this pen, if I break it down, if I crush it, ultimately I'll see some atoms there. So those are things. Okay, Redmi, there is no such thing as roll number. I did not understand the question. Okay, the weight is very low. Okay, density you people were saying, right? Okay, melted gold and gold. Melted gold and gold. Which will have more density? Melted gold and gold. Which will have higher density? Melted gold will have higher density. All right. What is density's formula, guys? How do we find out density? Elena, so the question, why does ice float on water? People were saying because of density. So that is the reason I asked density. Density is mass upon volume. Okay. Now I have taken 100 grams of water in liquid state. I have taken 100 grams of water in liquid state and I have taken 100 grams of ice. Okay. And in one case, I'm taking 100 grams of liquid gold. And I have taken 100 grams of solid gold. Now compare the volumes for me. Gold will have more weight. I'm just comparing liquid gold with solid gold. I'm just comparing 100 grams of water with ice. I'm not comparing gold with water. All right. So now I'm asking you, you said that ice floats on water. Many people just said that ice floats on water because of density. And one person has answered that density is mass upon volume. Now I said I have taken 100 grams and 100 grams, right? So will the density still differ? If so, why? If so, why? Guys, I'm not going to leave. For every question, if you attend my classes, you'll know. Without asking the question why, I never leave the students. Volume differs. Why does the volume differ? Both is water, right? What is the composition of water? What is the composition of water? Guys, even if you're wrong, it's okay. You just have to interact with me, right? That is what we are doing. Everyone is learning. H2O. H2O. That's right. H2O, hydrogen and oxygen. So in both of these things, there is hydrogen and oxygen, H2O. But why is it differing? Why is the volume differing when it is in liquid state? And why is it differing in solid when it becoming a solid? And my question about gold, if I take a liquid gold and solid gold is more dense. So if I have liquid gold, solid gold will go and settle down in the bottom. That is what will happen. Solids are generally more dense. What is happening there? State is different. What is there? Ultimately, there is only molecules, no? Molecules of H2O. But why should it change? Why should the density change? Why should it float? Anyone? Intermolecular space differs. Okay. But why is it different for a gold and why is it different for an ice? So this is what we are going to be doing in the classes, okay? I get you all confused. I asked a lot of questions and finally I'll give the answers. Yeah, by the end of the sessions, you will be giving the answers to me. So guys, what happens is one person explained it correct. Intermolecular space differs. But that is one thing. Yeah, intermolecular space, as I was saying, intermolecular space plays a very important role. The other one which plays a very important role here is intermolecular force of attraction. Force of attraction. So now what happens between ice and water is when it is in ice form, that is when it is 0 degrees Celsius, ice arranges itself. That is, the water molecules, the H2O molecules arrange themselves in such a way that they are at a certain distance from one another because the temperature influences the kinetic energy. The temperature influences the kinetic energy. Kinetic energy is what gives the speed, the motion. So, because of that reason, the intermolecular force of attraction is different in case of water. So it will arrange itself in such a distance that it has to be a bit far from each other. Only then they will have that force of attraction. So that is the reason the intermolecular space increases, and when space increases, the volume increases. So when volume increases, density's formula is mass over volume. So if I take 100 grams of water in liquid and 100 grams of ice, both have the same mass, but volume would be different in case of a water and in case of ice. Ice will occupy more volume. So you can actually try it out freezing a glass of water. Just take a glass of water full and try to freeze it. Okay. Ever observed when you fill ice trays? Ever done that at your houses during summer? No, no housework, people. So what do you do is, yeah, when you fill the ice tray, you will observe that the ice cube bulges out of the tray because ice occupies more volume when compared to water. So it is a simple thing because of space, but when we actually get into it, you can't just tell me density and be done with it. I'm not going to accept it. You have to get down to it. So that is what we do during the class. Was this clear for everyone? So this is a special exception only for ice because the kind of attraction which is present here is different. Okay, guys. And the other question what I saw was thunder. What is the thunder? What is plasma? What are the states of matter? So we'll be leading at 5 states of matter, which is solids, liquids, gases, and there is one state called as plasma and another state called as Bose-Einstein condensate. Okay, more on this we'll be discussing in the class. This plasma state is what is composed, that is all this lightning is composed of plasma states. Solids, liquids, gases, plasma, Bose-Einstein condensate. Okay. Renuka, ice doesn't have tightly packed. Ice will have molecules packed at more spaces. The molecule space is more. So Akshara, more on these states we'll be discussing during the class. Okay, but now I have few questions. Sounds good? Yeah. So that was about the plasma state. Okay. Plasma state is nothing but what you see in lightning and aurora. So all these interesting videos and all these things we'll be discussing in the class. And I make sure the class is interesting. Now a question. Everyone knows what happens when solid converts to liquid, guys? What happens? What is that process called? Solid converting to a liquid. Melting. Why does that happen? Why does that happen? When I increase the heat. That's right. When I increase the heat, I can see that the temperature is also increased. Now, if I'm converting liquid to gas, what is the process called? What is the process of conversion of a liquid to gas? Is it evaporation or vaporization? Is it evaporation or vaporization? Is there a difference between the two? No? Is there a difference between the two? Sun is made up of a lot of stuff, Elena, but the solar flares, the heat which you get from the sun is again made of plasma state. It is also a state of matter. Okay. Vaporization and evaporation. Okay. People say there is a slight difference. What difference do you think it is? Dia is not replying. Why? Dia, please feel free to reply. Huh? Yeah. Evaporation happens naturally at any temperature. Okay. So even at 0 degrees, can the water evaporate, Neon? So whoever know the difference, they can actually say that. You can just type it because I can't unmute you at this point, right? There are many people who want to unmute. Yes? No. Okay. So a small difference because you had taken the term evaporation, the liquid converting into gas, right? There are two things. One is evaporation and the other one is vaporization. But they are two completely different processes, guys. Vaporization is something when I heat up a liquid and the heat is transferred throughout the liquid, the molecules or atoms which are there will take this heat and there will be increase in kinetic energy. They will take up the heat, the kinetic energy will increase and they'll start rapidly moving. When they start moving, they will have an amount of energy that they can start escaping into atmosphere or they start becoming gas molecules. So this whole process where the liquid molecules will start converting into gas molecules will happen through vaporization or else we call it as boiling. Ever boiled water? Ever boiled water at your house? Made tea for your people? Right? So that boiling is what is called as vaporization. Now the clothes also dry, isn't it? Whatever clothes you wash, you keep them to dry out in the sun, isn't it? What do you do there? Is it still wet? Are you boiling the clothes? No. How is the liquid going out? The liquid is still not there, isn't it? That process is evaporation. That process, my dears, is evaporation. Okay, something is happening to the pen. So evaporation is something where if there is a layer of liquid, a very thin layer of liquid, and the atmosphere, suppose I put fan to a wet cloth, it gets evaporated much more easily. Am I right? It evaporates much more easily because the surface molecules, what they do is they give that energy. They will pick up that energy, all right? High energy molecules just from the surface and remove them. That is the reason when you mop the floor, you can remove the water, or when the water is just thrown on the floor, the water is still removed, right? And even when you dry the clothes, the water is getting removed. So this evaporation can take place at any temperature, provided there is air, provided there is energy. So the clothes dry even when you put them out in the sun or in the shade, right? So that means that they will dry more quickly when kept in the sun. So how much energy is being given? This reason. Now, how many of you use this smelling detergents when you wash the clothes? You smell the detergent, right? Do you smell the detergent after washing the clothes? Ever done that? Yeah? No? So what happens is the liquid molecules, that is the water will evaporate, but the detergent which smells, right? Those compounds are still on the surface. They haven't evaporated. That is the reason you still get the smell. You understand? The reason why your clothes smell is because they haven't evaporated. That detergent, that smell, the molecules which cause that smell haven't evaporated, but the liquid has. That is the reason your clothes smell like they have a nice khushbu, they say, right? Nice smell because of that. Is this clear? So all these small tidbits is what we'll go. Now to the question, okay? Three identical containers X, Y, Z were filled with the same amount of tap water, boiling water and ice and left in the room. Which of the following graphs shows the change in temperature of the content in each container after some time? What do you guys think the answer is? When you take boiling temperature water and you have a ice and you have a room temperature water, what happens? Guys, if you give the answers, you have to give me the explanation. I got explanation only from one person. Prerna has given me one explanation. We will see. So X is room temperature. Y is boiling water. Z is ice. Right? Now ice, when I keep it at room temperature, what will happen? Ice will take up the heat, right? Ice will start to melt. Will it melt so much that it will start to boil? No, because whatever is your room temperature, it will stay to the same amount. That is, the heat will be to the same amount. So this is what happens to the heat energy. So what happens is when you add a hot water to a cold water. So ever felt the water was so cool that you added some bit of hot water and then had a bath, right? So what happens? The energy from hot water is transferred to cold water. But it is not going to get so hot, isn't it? It will eventually reach room temperature. It is not going to go too hot or less hot. So always when left just like that, okay, the heat energy which is achieved is at room temperature. How do we measure heat? Through temperature. So Prerna, the one thing which you missed in your explanation was something doesn't lose temperature or gain temperature. It will lose heat energy or gain energy only. Okay, Prerna. So what happens? The X will not gain or lose any energy because it is at room temperature. The Y, which is boiling point, that is boiling water, will start losing heat and the temperature is reduced, eventually reaches the room temperature, and ice starts melt, becomes water and gains energy so that it reaches the room temperature. It stops here. So the answer is B. Is this clear, guys? Everyone, was this concept clear? Can I see a thumbs up? So far, you enjoying the class? Boring? Class is boring? Just give me a thumbs up if you have understood so far whatever I said. All right. Rashmi, do we have time or do I stop here?
We can take another maybe 5-10 minutes.
Okay, sir. Okay, guys. Next question. Sneha set up an experiment for melting ice in a beaker and noted down the temperature throughout the process. What do you think she observed when the ice was melting? Akshra, even yours is good, but just about little bit about energy, small tweaks. Okay, Akshra? Yes, guys. So what do you think is the answer for this? We have ice and it's starting to melt and she just noted the temperature when it is melting. What will happen to the temperature? Once the melting point, okay, people are saying A and B. The temperature in thermometer kept increasing till the whole ice melted. Once the melting process started, the temperature in thermometer remained constant though the heating was on. There was no change in temperature. Ice did not melt on heat. So people are between A and B. Any explanations, guys? Okay, Prerna gave one explanation. So there is a small concept here, right? When we heat molecules, for example, when solid, ice is very, very closely packed together. Now, when I heat this, what exactly am I doing? I'm increasing the kinetic energy because the heat energy which is there will take up the kinetic energy. When it takes kinetic energy, whatever forces which are there between these particles will start reducing because, okay, don't spam. I have seen your message. Please don't spam. Okay, I'm seeing your explanations. All right, let me finish up. All right. Yeah. So increase in kinetic energy happens. So when increase in kinetic energy happens, what is affected? The motion of particles. Motion of particles increases. That means the space between the particles will increase because they start moving apart. And the intermolecular forces, whatever is holding together. So imagine your friends and you are shaking your hand, one person is pulling you away. So obviously you will move away from your friend, isn't it? So that force, that energy which is pulling off is what is kinetic energy, the motion. All right. So the intermolecular space increases and eventually it will attain a liquid state. Okay. Now back to the question. Here it says when it is melting, that means the solid is converting into liquid. Here what happens is when solid is converting into liquid or when liquid is converting into gas also, at that point where ice is just starting to melt, the energy would be sufficient that the ice has energy that it can become liquid. But there are small tweaks to be done. What are the difference between solid and liquid? Solid is rigid, it is not flexible, it is very hard, isn't it? And when compared to liquid, liquid has a lot of space, it can flow, right? It doesn't have a fixed shape, isn't it? So it has to attain all these properties. So when ice starts to melt and when the energy is still provided in the form of heat, you know what will happen? The ice will take this energy only to arrange itself so that it starts behaving like a liquid. It is like today you entered into the class and you were waiting for the class to start. So what did you do? You entered the ID and did all this and you entered the class and you were settling down. So you entering the ID and everything is that the ice is ready. It has attained some energy and it is ready to become liquid. What are all the things it has to done? It has to start behave as a student. Like you have to start behave as a student, right? So what do? You arrange yourself, you fix your laptop and you have to start chatting, right? So you're arranging yourself. So similarly, the liquid also has to arrange itself. So what happens to the temperature is, this is what happens. At 0 degrees Celsius is where the ice melts. So when I suppose I have my ice at -5 degrees Celsius and I am increasing the temperature to 0 by heating it up. So at this point, there will be increase in kinetic energy and ice is taking up a lot of energy. The motion is increasing. Okay. Now at 0 degrees Celsius, the ice is ready to melt. What will it do? It will start arranging itself. So whatever heat I will give, it will take up only to arrange itself and behave as a liquid. So until the ice completely converts into liquid water, there will be no change in temperature. There will be no change in temperature. Why? Because whatever energy you're giving in the form of heat, right? It is taken up by ice to just arrange itself and get all the properties of water. It is not going to do anything. It is just going to arrange itself. After 0 degrees Celsius, if the temperature is increasing, that is once when everything has become liquid, the temperature will start increasing again when you heat it up. It will reach room temperature, all these things will happen. Is this clear, guys? Is this clear? So when we heat it, yes, Adil, minus 5 degrees Celsius, it is still ice. And at 0 degrees Celsius, it will melt. But when the temperature is changing from minus 5 to 0, what do you think is happening? Don't you think the energy in the ice is changing? Ever had ice cream just fresh from the freezer at minus 20 degrees Celsius and at 0 degrees Celsius? Ever had a difference in ice cream? The texture, it will be much more hard when it is very, very cold, right? And once when you slowly started it, the temperature is at 0, slowly it will start to melt, correct? The same thing is happening with ice. When it's at minus 5 degrees Celsius to 0 degrees Celsius, the energy is increasing. The ice is taking up all the energy and it is reflecting as the temperature. The heat, whatever it takes up, reflects as temperature. Okay, the temperature what you measure is nothing but heat. Yes, so the temperature won't increase in thermometer when it is melting, because whatever energy is there, it is not showing it towards increase in temperature. It is using it towards arranging itself. So the temperature will not increase. Do you understand? Yes, that's it. So at 0 degrees, if you look exactly, next time you're doing this experiment, if you look at 0 degrees, right, there will be both ice particles, there will be both water particles. Both of these things will be there at 0 degrees. Even at 100 degrees Celsius, liquid water will also be there. Water vapor will also be there. Until everything has been converted to water vapor, the temperature will not rise. So if you have a thermometer at your home, you can check it out. Huh? This is one cool thing, right? So whenever one state is converting into another, there will be no change in temperature. One state converting into another, there will be no change in temperature. Clear, guys? Yes? So the answer would be B. Yes, only after melting completely, the temperature will rise.